Section 11.3, Shapes of Distributions. We're going to look at one last way to display data here and discuss the shapes of this. We've so far discussed box and whisker plots. Today we're going to look at histograms. And a histogram is a data display that shows the number of data points that fall into equally sized intervals. Alright, and so what we have here is an example of a histogram. And it's a histogram that shows the number of raffle tickets sold by students in a particular class. And you can see here that we have the number of tickets sold, and we have a little collection of intervals here. Each interval, you'll notice, is contains 8 different values, 1 through 8, 9 through 16, 17 through 24, and so on. And there are 7 such intervals. And all of those are the same size. They contain 8 values. And what we see here is a frequency distribution on the left side, the y-axis here. And what this means is that there were 5 students who sold between 1 and 8 raffle tickets. So we don't know if all 5 sold 8, if 3 of them sold 4 and the other 2 sold 7. We don't know, but we do know that there were 5 in that range. Similarly, it appears that there were 9 that sold between 9 and 16 raffle tickets. It looks like there were about 16 who sold between 17 and 24. It looks like there were 25 that sold between 25 and 32. And looks like 20 sold between 33 and 40. And this one's a little bit tougher to tell, but it looks like it's just a little bit below the one we saw before, so we'll call this 8 students that sold between 41 and 48. And finally, just one step below that, looks like there were 7 students who sold 49 to 56 tickets. Now, from this this histogram, there's not much that we can really figure out in terms of specifics. It's even less specific than a box and whisker plot. We can't guarantee what the mean is. We can't guarantee what the median is, although we might be able to find a range for it. We can't figure out the mode, although we might have an idea that the mode could be from one of the regions where there was more a higher frequency of the tickets sold, but we can't guarantee that. And we actually can't even guarantee the range, although we could put a cap on it and say that the range would be at most 55, because we know the highest number possible would be 56, the lowest number possible would be 1. So the maximum range would be 55, and I guess we could have a minimum range. We know at least 49 and 8, so I guess 41 would be the minimum range. So somewhere in there would be the actual range, but we can't guarantee that we necessarily have someone at either extreme there. Anyways, the one thing we can figure out is a range. Which of these intervals, which of these 7 intervals, is home to the median? And the way we do that is we'd figure out where the middle number would be. If you look at all of these numbers here, these are going to add up to a total student population of 90 students. And so if there's 90 students in total, we'd want to find the halfway point. Well, the halfway point, if we divide by 2, we're looking at the 45th student. Now, because it's 90 students, it's going to be coming in from both the left and the right, and it's we're going to have 45 from each direction, so we'd have to average the 2 middle students. But where are those students? Well, if we look at the first 3 intervals here, there are 5 students, then 9, and then 16. Now, while we don't know the particular numbers of tickets that they sold, we do know that those would account for the first 30 students. Similarly, on the right side, if we look at the final 3, that's going to account for 35 students. And so the students on the left side of this, the from 1 through 24 tickets sold, are the first 30. And students from 33 through 56 tickets sold account for the final 35. And that wouldn't be at our median yet. So we'd have to go into this final interval. And this is going to be the interval that's going to contain our median. And so while we can't say for certain what the median is, we could say that it will be between 25 and 32. And that's the one thing that we can really say for certain here. But that's what a histogram looks like. It looks like kind of a bar graph. The bars are directly adjacent to each other. They touch, and we're looking at just intervals that are the same size. In this case, we chose 8 to be the size there. 10 is a common one. It depends on what the data is looking at. And that's how you would read a histogram. So let's try to make one. Okay, so you can see here the data in the table that shows the number of pounds of aluminum collected in a local can drive by various Boy Scout troops. And we're going to construct a histogram to represent the data. Now, we're actually told what our intervals are going to be here. They're 10 units in width, 1 through 10, 11 through 20, and so on. And it appears we have 1, 2, 3, 4, 5, 6 such intervals. And we have our frequencies right here. And so what we're going to do is we're going to construct a histogram. It doesn't need to be anything fancy. We're just going to do kind of the best that we can. So I'm just going to put this in here, and I want to label my intervals. I want to make them the same size here. So I need 6 of them in total, so I'm going to try to get them pretty equally sized. Just doing my best here. And we've got 1 through 10, 11 through 20, 21 through 30, 31 through 40, 41 through 50, and 51 through 60. And this is the number of pounds is what we'd put here. We want to put a label on it. And then we have to have our frequency going up the side. And so we have our frequency here. And we need to go up to at least 34. So I'm going to go by 5s maybe. 5, 10, 15, 20, 25, 30. I'm just going to give myself a little bit more space here. We'll go up to 35. And it's probably helpful to extend this all the way across. If you're doing this, I would recommend using a ruler. I don't have that luxury on here. Drawing lines on here actually is a bit tricky. But I think this is looking alright. It's pretty solid. Not my best work, but it's okay. And now we're just going to fill in what we can. So from 1 through 10 pounds, we had a frequency of 7 there. So we're going to go not quite halfway between 5 and 10. And we can fill that in if we want, kind of shade it in a little bit there. 11 through 20, we go up just a little bit higher, up to 8. Again, it's directly next to the other bar graph. It doesn't. There's no gap in between there. 21 through 30 goes all the way up exactly to 10. So you fill that in there. All right, 31 through 40, all the way up to 16. That's a nice little jump. So we continue up here, just past the 15. Fill in our histogram there. Or that interval, 41 through 50. That was the big show. That's impressive, almost all the way to the top. And just shade it in. It's just all the way up to 34. That's a big section there. It's pretty good. Nice job to those troops. And then finally, 51 through 60. Our final interval up to 15. So that's kind of our last interval there. And that's how you have it. That's your histogram. So at this point, I want you to take a second, pause the video, figure out where the median would be, which of these intervals, and then come back and check your work. All right, let's see how you did. All right, so your median should be in the 41 to 50 pound range. There are 90 total Boy Scout troops that are being considered here, and the 45th or the 46th, the in between there would be where our median is, and that's actually right here. It's a very high number of data points in that interval, so that's not surprising. It's probably where the mode is as well, and perhaps where the mean is, although the mean very likely could be in the 31 to 40 range as well. Depends on the actual numbers. All right, hope this is pretty clear. So just kind of wanted you to see the different types of histograms and how the data can look. This is very similar to the type of skew that occurs with box and whisker plots. Sometimes we have what we call the tail of the histogram extending to the left, and that's what happens when there's a large amount of data on the right side. The boxes are taller on the right side for the most part, and we call this skewed to the left. This tail here is extending to the left, just kind of like in a box and whisker plot. When the whisker extends to the left, we call that skew left. The opposite is true if it's skewed right, when most of the data are on the left side. The histogram demonstrates that there's a larger number of data points on the left. The tail extends to the right, and that's going to be skewed right, very similar to the box and whisker plots once again. Finally, we have what we like to see, which is called symmetric. And that forms a nice shape. Kind of looks like a parabola here, but it's not, because it turns back out. This is really nice, and this is actually, it's going to be called symmetric even if these are all pretty even. If it's pretty flat, it's called a uniform distribution, but that too would be symmetric. Basically, if it looks like it's almost a mirror image, then it would be symmetric. The last example that we looked at is pretty much skewed left. The previous example was pretty much symmetric. Maybe just a slight skew, but that was pretty symmetric overall. So that's the types of skew that you can have. That's some of the shapes of the distributions that occur. And just one closing remark on choosing the appropriate measure to represent the data. If we have a symmetric distribution, then the mean is really a good option to use. It often will be very close to the median as well, but the mean, which should appear probably right in the center with the median, would be a good representative measure of center, and standard deviation or range or anything like that would be a good way to describe the variation. Standard deviation is a little bit more complicated to calculate, but if we have access to calculators or a spreadsheet, then it would be worth using that there. But when something is skewed, and sometimes that happens because of outliers, then the mean can be kind of artificially changed. We've seen some examples of that in class, in which case you'd want to use the median. For example, here where this histogram is skewed to the left, you can see that the mean gets pulled down. It's smaller than it really should be, and so we'd want to use the median as more of a representative number here. Over here we have a small number of data points far to the right. Those are the outliers on the right side, either technically outliers or pseudo outliers, and they artificially inflate the mean, making it larger than it should be. And so in that case we'd want to use the median as a more representative measure of center. And when it says here to use the 5-number summary to describe the variation, the 5-number summary, remember that is the least value, the greatest value, and then the three quartiles. Q1, also known as the lower quartile, Q2, also known as the median, and Q3, also known as the upper quartile. Those 5 numbers which we use to plot a box and whisker plot are a way to describe the variation there. Standard deviation can be messed up a little bit because the mean has been thrown off and the standard deviation is so connected to the mean. And there you have it, guys. That's the end of this section. And that's also the end of the videos for this year. So I really hope that this was something that you found beneficial. It was something that I took on as a challenge to myself, and I hope that it has worked out. I really appreciate all of your feedback and your patience when things haven't gone particularly well, and there's been some technical difficulties. But I hope you found this very beneficial again, and I want to thank you for a really great year. And best of luck in the last couple of weeks of this class. And enjoy your summer, and best of luck in geometry next year. You guys are great. Thank you.